Alright, hello, welcome to Ekidel, where we train future civil and structural engineers. My name is Fashe Ochet. Today, we want to train you or to show you how to design or to have your detailed drawing when it comes to retaining wall or basement design. We have done a lot of videos on basement design, and before we proceed, I want to say that I'm going to be using a Protastructure 2024, the latest version of Protastructure, which is a 2024, to be doing this particular video. So what we want to learn today is how to detail your retaining wall, how to design your retaining wall. That's what we want to concentrate on today. When it comes to the retaining wall, it's not something we can finish today. I want to have that at the back of your mind. So we only take one aspect, deal with it today, and then next time we also take other aspect of a retaining wall. We cannot finish everything today. Is that okay? But to some extent, what we are going to be doing today will give you confidence when it comes to what either basement design or retaining wall. At least you should be able to design retaining wall. Is that okay? So that is that. Now, the moment you get to this point, when you have finished your design, analyze and design here from Protastructure, you have done your basement. You can see the basement here. It has been loaded. Is that okay? It has been loaded. And how to load your basement wall, it has been what? We have done video on that. So go to our Ekidel YouTube channel and search for the video. Definitely you'll get how to load your retaining wall or your basement. So that is that. Now let's now proceed. The moment you have finished everything, the next thing to do is to come to what? Drawing report. Is that okay? Drawings and what? And report. So once you have clicked on it, so come to what? To Prota Detail. And the moment you click on Prota Detail, you are going to be having this. Is that okay? And once you have this, are you with me? So once you have this, the next thing to do, because as I said, we want to design our retaining wall. Please, as I said, so we need to concentrate and follow me as we'll be going. Is that okay? So now once we get to this point here, so all I will need to do is to click on Design Library. And once I click on Design Library, so I'll come to cantilever retaining wall. So I'll click on it and then I'll wait for it. Is that okay? So as I said, we are designing a retaining wall. Is that okay? So that is that. So let's wait for it as it comes up. So this is it. Now we know that the purpose of our retaining wall is to help us hold back the soil, isn't it? So now we are going to, just like the bridge, is that okay? Your basement, for bridges, for basement, these are the things that we use to retain our soil. So now this is where you input your dimensions. Is that okay? Very, very important. Now let's start looking at this. But before then, you can see if I click on this shelf, you can see the kind of retaining wall we will be having. Is that okay? So you can see. So like a day will come whereby we'll discuss on this. Is that okay? That is that. So we don't need that for now. So if I also come to this place, that's one side of a retaining wall. Then you can see another one called parapet. So you can see it here. So that is that. We are not discussing this one today. Other time we also discuss that. You can also see this type with with share key. At what point do you use this? I think this one, we are going to explain this one in this video because it's very, very important. So you can see it. You can see the image here. So that is that. So click on this again. Let me remove it. So now come to this place. It's already what we are having here. Is that okay? So you have this one without a share key. So let's see. So you can see it here. Is that okay? So all of this will be discussing, though not like this. So we might not be touching everything, but the part we are going to be touching today will seriously help you. So follow me as we continue in this design of retaining wall. Is that okay? Or your basement. So now when it comes to the total wall height, is that okay? Total wall height. Now based on this drawing, the height of my basement is retaining wall is 3 meters. Is that okay? Which is 30 meters, 300 rather, which is 3000 millimeters. So I'll enter my 3000 millimeter. Is that okay? Then I'll come to this place and say yes. Now this is a 3000 millimeter. Don't worry, everything will be adjusted. So now after I've entered my height, you can see from here to this place 3000. But don't forget that from here to here, I'm going to have I'm going to have my my toe at the same time my heel. So but before I proceed, you can see this vertical wall is called stem. Is that okay? This is called stem, and from this point to this point is called your toe, and from this point to this point is called your heel slab. So now the combination of this toe and also your heel slab make the foundation for this your vertical stem. Is that okay? For this your stem. Is that okay? So and we have a top stem and the bottom stem. So let's proceed. Now if you look at the total height from here to this place, we are saying is what is if I say what is my height, I'm going to use 3000. So my t here is going to be what 300. Is that okay? So which makes the total height of what 3300. 3300 is that okay? Am I correct? Yes, 3300. Come to this place now. Say yes. Now, what about my height? My height from here to this place is 3000, isn't it? Now coming to this place, looking at the type of what I'm using is what my t is what is 300. Is that okay? It's 300. Okay, now casting height, my casting height is what? That's from this point to this point is what is my casting height. So it's going to be the same thing with what with my total wall height. Is that okay? So my casting height will be the same thing with what with total wall height. Is that okay? So that is that. Then another thing is, what is the wall length? This retaining wall, what is the length of this retaining wall? Is that okay? So what is the length? Looking at this from this point of column to this point of column, what is the length? Or from this point to this point, what is the length? And if your own retaining wall is from this point to this point, you are going to enter it. Is that okay? So let's proceed. So my own length, let me say the side I'm designing, let's say I'm using the maximum length, maybe it says 5.5, 5500 length. Is that okay? So that's my length of my what of my retaining wall. Is that okay? So that's that. Then stem top width, which is this place. Is that okay? Which is this place. Now how do you get this? Let me look at my calculator. How do you get this? When it comes to basement or retaining wall, it says that one of the rules is that the minimum stem width you can have is the 10% of what of your height. So if I'm using the height, my height from here to this place is what is a 3000. So from here to this place, this one here is a 3000. So it's 3000. Okay, sorry, 3000 multiplied by 0.1, which is equal to what 300. Is that okay? So 300. So my minimum stem top is what is going to be what 300, which is already there. 300. Is that okay? 300. Then when it comes to eccentricity, now eccentricity is in the sense that if you look at this stem, we always call this one stem when it comes to retaining wall or cantilever, sorry, or retaining wall. So we call this one stem, and if you look at this stem, it's not straight. Is that okay? It's tilted to this other side. So when we talk of eccentricity, we want to make it straight. Is that okay? I want it to be 0, and the reason is because if I should not make it 0, if I make it 200, don't forget that inside this place, we have people are living inside this place. So my wall should not be bent, isn't it? So my retaining wall should not be bent. So I'm going to make it what straight. Is that okay? I'm going to make my eccentricity to be 0. So once I click on 0, I'll click on the next one. So you can see that it's straight now. Can you see it now? So this is how it should be. So that is that. And then if you also come to this base plate from what? From front length. Is that okay? So which is what? B. Is that okay? And which is my toe? Is that okay? This is my toe. So and for my toe, I want to use this one. It's too small for me. Those still based on design. Let's just start with let's say 500. No, I want to use 1000. Okay, so you can see it here because it helps a lot, because the force here, though as we are going to be, I'll be explaining that. So the force of the soil that is pushing this one will help to resist it back. Is that okay? So this tool here is very, very important. So for me, I will make it 1000, though because of design. If it fails, then you can do something about that. Then coming to bottom stem. Now my bottom stem, at times, let me do something here. If this place is 300, I also want this place to be 300. So it's already 300. But in a situation whereby I want my stem bottom width to be more than that of a top, I can make this one, let's say 450, so I can see what I'm talking about. So do you see it now? So can you see it? So you can see that the width from here to here is more than from this place to this place. So but what I want is I want it to equal. Is that okay? I want the same 300. Okay, so you can see it 300. So that's that. Then base plate back length. Is that okay? Which is my B3. Now this is a place B3. So this is what, and this is a 1650. This 1650, it depends on you or in the course of design. But for me, if I make this place 1000, to let me make this place 1800. Is that okay? 1800. Okay, so you can see it has been adjusted. So that is that. Now once I'm done with all of this, then I now go to my soil property. Now in this place, my soil property, this one, based on the report, your soil report, that's what you're going to use for this. Is that okay? Based on your soil report, you are going to be using for this. Whatever be the value given to you, you are going to. If I click on this, now what type of soil am I using? Am I using a my topsoil, which is natural soil, or sand or gravel disc, and also or sand or gravel saturated? So I'm going to use let me use this one for what's condition. Let me use this one as 20. Is that okay for this? I'm using 20. Is that okay? I'm using 20 for this. So let's assume a worst condition. Is that okay? So based on the soil, after soil test being carried out, you get to know the value of this. Is that okay? The type of soil. Is that okay? So that's that. All other ones from your soil report, you are going to get them. And coming to this place, you can see soil bearing capacity. Our soil bearing capacity of that place is 120. 120. So it's 120. Excuse me, 120. And when it comes to base friction coefficient, is that okay? So base friction coefficient, you see coarse sand or gravel with what high permeability, and look at seed sand with what this. So I'm using what the first one, which is still okay for me based on the report. So that is that. And also this value here, minimum allowable minimum allowed soil bearing capacity, this and this. So it's very okay too. So that is that. So I haven't done this one like this, touch everywhere here. Then the most important thing aspect also, which one of the most important aspects is this backfill. So let's see. Now coming to this place. Now, what's the height of your fillings? The soil that you're going to fill, what is the height for the backfill? So it's what? Since it's at what 3,000, isn't it? It's at 3,000. So don't forget it was 3,000. It was 3,000 we used, isn't it? It was what 3,000. Our height is what 3,000. So I'll come to my backfill. So what we are going to be putting is what is 3,000. It's 3,000. Is that okay? That's 3,000. Now after that, then I'll come to this place. Height of water table. Now what is the height of your water table, which is this? Is that okay? Water table is don't forget that the moment there is water settles here, is going to add additional force to this retaining wall. Is that okay? The force on this retaining wall will increase. So, and that is why there's need for what? For whip holes or draining holes. Is that okay? So that's in order for you to drain out. And if you notice, if you go to bridge side, you will discover that if you are under the bridge, you would notice that part of the wall is what is wet, like greenish in color. Yes, it's because of that whip holes or draining holes. Because with the help of that, the water is now being settled here, which now add additional load to this retaining our stem. Is that okay? That is that. And for that to also happen, you also notice that for proper draining, we would normally have a coarse aggregate very close to this before the soil. Is that okay? That is that's that. So what is the level of your what do you call it, water table around this place? So if it's 1,000, good and fine. If it's 1,002, you also enter the value. So that is that. Now coming to this place where we are talking about surcharge load type. Now if you come to this place, don't forget what we use. If I click on this, right click and go to edit load, and go to edit load. From edit load, let's come up. Okay, let's come up. In case you have not subscribed, I want to say you should click on subscribe button. It's very important to help us to do more on what this video production is. Okay, very important. Subscribe and also like this video. So now having clicked on it, so let's wait for it to quickly come up. Is that okay? Okay, as you can see, it has come up. Now let me play go. Then select this. We are talking about surcharge. Is that okay? So as I click on this, let's wait, it has come. So I click on this. Let me go to my surcharge. You can see. So from here it was set. It was see what you can see. Yes. At this point, we are not using point load. Is that okay? Because we are not designing for pipe. Is that okay? So if you are designing for pipe, yeah, that's why we can use this. So we are not using pipe that will penetrate through through our retaining wall, because the point at which this pipe is resting on the on the wall is what is acting as what point load at that particular area. But since we don't have that, this one is not what it's not a point load. So we are going to remove this. Is that okay? I remove this. So which means what we use here is what is a surface load. Is that okay? It's a surface load we are using. You can see any other load we have it there. So surface load we are using. So and what's our value? Our value we are using what 20. We have explained this in the course of our previous video. So if you want to understand this aspect, just go and watch those videos. Then that is that. So I will now click on OK, and that is that. So you can see surface load is what we are using, isn't it? We are using surface load. So let me now go back. We are using surface load. So at this point here, I'm using surface load. So can you see now? The surface load I'm using, and it's called, here's what magnitude of our distribution. And don't forget that our magnitude when we came here was our magnitude 20, isn't it? So I'm coming to this place and we use what? I use my 20. Is that okay? 20. All right, kilonewton per meter square. So that is that. Since I'm using a what backfill, is that okay? That's my value, and this one field, okay, is this. Then also come to what this place of setting. Now, at this point, the retaining wall or your basement wall, what is doing, the force that is acting on it is what is active. It's on the active side. Is that okay? So we don't really need a passive. Though there are conditions in which you have a what passive, but in this case, because we want to retain the wall back, what do we have? What is the force that is acting on that wall is what is a active earth pressure. Under lateral pressure, we have active and we have passive, isn't it? So now, but the one that is acting fully on the soil is what, on the retaining wall, is what is a active earth pressure, so which is on the active side. So that's why all of these are being checked. And if you look at this place, stem weight, yes, our stem, the weight is very important. We need it. I will include it. Then base plate weight, I also need it. Then also self weight, very important. Is that okay? Very important. So that is that. Then having done all of this, the next thing to do is we can come to what? Let's see, design settings. Good. At this point, is that okay? At this point here, we are going to choose what? Choose your concrete type. So which grade are you using? Are we going to be using? So once I click on it, so let's wait for, you can see either grade 25 or grade 20, whichever one, but I'm going to use what? Grade 25. Is that okay? I'm using grade 25. I'll click on OK. Then if you look at rebar, under my rebar, so I will also have what? 410 or 460. So I'm using 410. So apply to all. So okay. Then the same thing for my link, the same thing. So come to my bar link. So on this point here, I'm using let me remove this. Let me use this. No, let me use 12. Let me also use 16. Where 16 is 18, this is 16. Okay, and let me say 20. Is that okay? Do I need 20? Let me just put 20. Is that okay? So, and also watch one again. So just make your move around this. Then you have your this one I've also been written in other videos. So is that okay? So let me just remove these ones. I don't need these ones. I don't need this one. I don't need this one. This one. Okay, let me leave 10. No, I don't need this. Okay, let's leave that this. Okay, so now I'll click on what? Okay, my link is very important. I'm using 10. I'm using 10 for the link. So you can see I'm using 10 for the link. Okay, I'll click on OK. Now, having done this, I'll come to my code. Now, whatever code we are using, either Euro code or American code, is that okay? That's what you choose. If you like, you use American code or Euro code. That is that. So now I'll come to my concrete cover. Since we are talking of the soil, for me, I want to use, it should not less than 50. It should not be less than 50. Is that okay? It should not be less than 50. Or let me make it 75. Let me make 75. 75 is okay. 75 is okay. 75 is okay. 75. Okay, that is that. And having explained all of this, now the next thing we are going to be, earthquake parameter. If there's earthquake, is that okay? If the earthquake is in the place is prone to what, to seismic or earthquake, so you can enter those value all the from your report. We should have all of this ground type and all of those things was entered. So that is that. And once you have done this, the next thing, now if you look at this, you can see overturning safety. You can see all checked. If you look at sliding, is that okay? Sliding. Let me now explain this. Let me come back here. So if you now come to this place, when this sliding is failing, when you're having a failure and on this sliding, now apart from increasing the thickness or the your stem, you can provide what we call shear key. Is that okay? Because as the earth is pushing this, definitely this one will also be moving away, and to avoid that movement, we provide what? Shear key. Is that okay? Which I've shown you initially. It will appear here, which means that if you are digging your trench top at this place, at this point here, maybe around this place, is that okay? Or here, around here, where your stem is, around here, you can now dig further. And the width of it, since it's a 300, it's going to be also about 300. I say want to give for a space. Is that okay? Space for it, for your cover and all of those things. So that's what you're going to dig down, which the depth of it will also be what? Will also be entered. So that is that. So when you are having a failure here, you can provide what? Shear key. Is that okay? So that is that. Having explained all of this, now I will now go to my what? To my let's see. Okay, analysis null. After this one, yes, I'll come to what? To my design. Yes, design. I click on design. So let's wait for it, because this place have to be what? Be designed. That will be checked. Is that okay? Let's see what is going to happen. So let's see. Good. You can see design is what? Is successful. Can you see now? Our design is successful. So let's look at the stem. Let's look at the stem. So you can see the stem is okay, it's saved. Okay, okay, okay. Okay, then base plate. Okay, okay, all right, okay, also okay. Now let me go back to my design. Now if you look at this, we have 1.1 under total failure, 1.19 greater than what? 1. For me, it's not too okay because it's too close. Is that okay? It's very too close. So all I can do, or let me go back and choose the, let's say 350. Let me use the 350 here. Where are you okay? Come back to this place because I'm changing it. I'll make it what? 3,350. 3,350. Is that okay? And then automatically this is 3,000. And also come to this place. Yes. So come to this place. Top height. My top height. Let's see. 3,350. Okay, you can see failure here. So no problem. That's not a problem. So now 3,350 and my wall height is also 3,000. It's what? 3,000, not 3,350. That's 3,000. Okay, 3,000. Let me enter. Okay, that's my height. And also come to this casting height is 3,350. Okay, and also wall length is the same thing. Now this one, this my thickness, I can make it 350. You know, based on that formula, that's the minimum, isn't it? So that is that. And also come to this place. 350, and also this one B2. Where's my B2? No, B1, which is the base plate front, which is my toe. This my toe is too small. Let me make it this. No, 1,000. Let me make it 1,000. Okay, come to this place. Okay, click. Okay, you can see that's passed because of this. That's passed. I've increased it. Okay, and then come to this B. Since the top is what? Let's check. Where's my A? Is 350. I'll also make this one what? 350. Is that okay? 350. Okay, that is good. And then here 1,100, 1,700, which is this place. Is that okay? And everything seems okay. So let's now design. Let's redesign. All the parameters still remain the same. So I'll click on design. So let's wait for it to come up. Let's wait for it. Is that okay? So let's see if there will be increment. Is that okay? Let's see if there will be increment. Maybe small. Okay, no much increment. Is that okay? So for us to have increment, let me now go back. Let me go back. I still want to increase it. For me, it's not too okay for me. So this place, let me make it 400 and see. 400 and come back here. Okay, 400. Okay, what is again? Let me make this one 1,200. Okay, 1,200 and this one 2,000. Okay, so let's design and see. Let us design and see. Okay, as you can see, it has increased. This is now, it has increased. At least it's a little bit far from 1. Is that okay? So I'll click on my what? On my design, because it's showing what design must be renewed. So therefore I'll click on what? On my design. Click on my design and let's wait for it. Let's wait for it. Let's wait for it to design. Okay, it's coming up. So in case you have not clicked on subscribe button, I want to say click on subscribe button so that you can continue to get our videos, and not only that, so that you also click on what? On like button. Is very, very important. Thank you so much. So now if you look at this, it has increased. Is that okay? You need to make some adjustments. Is that okay? To now see that yes, at least we have a higher differences. Is that okay? 1.25 greater than what? 1.00. You can see total failure is what? It's what? It's okay. That's showing us okay, and design is what is successful. Now, having done all of this, so your stem, you can check your stem. So you can see your stem. So you can also check your you can see your stem here. So you can see it. So you can also see your plate. So this place is what? It's our base plate, which is here. You can see everything is okay. Everything is okay. 50 white, 16. Okay. So that is that. Then having done all of this, everything is checked. You can see checked. And our total failure is what? Is 1.25 greater than what? 1. And design what? Is successful. Stability analysis are what? Are successful, and this and that. So for you to now get your drawing detail, you now click on what? On prepare drawing. So click on it and let's wait for it. Excuse me. Now, as I said, we cannot finish everything at once. But this aspect, what we are doing today, at least to some extent, it will help you to have the idea. And in case you have a wall or basement or retaining wall to design, at least with this you should be able to do something. Is that okay? And where the report are needed, you do what? You get it from what? From your technical engineer. Is that okay? So your technician. So let me click on this and let's wait for it. Is that okay? So let's wait for it. Let's wait for it to come up. So let's wait for it. You can see it has come. So now if you look at it, if you now see it, what's our height? Let's start from there. We say our height was 3,350. Remember, as we change it, isn't it? So that is that. And then if you look at from here, from this point to 3,250, so, and that is that. You can see when we increase to 400, you can see our thickness. Is that okay? The thickness of our foundation for what? For the stem. Is that okay? Our T1, you say our T1 is what? Sorry, our T1 is what? It's a 400, and our toe, the length of our toe is what? It's 1,002. And if you also look at this place, we say it's what? 2,000 from this place. Is that okay? That's by our heel slab. From here to this place, our heel slab is what? Is 2,000. You can see every information, every data we enter are accurate. They also give us the results. So you can now see crushed stone, as I was explaining that time, that before proper draining, what happened? We only have what? A form of a quartz aggregate around here for proper draining. You can now see our whip holes. You can see whip holes. You can see whereby the water drain out. You normally see this one in bridges, but when it comes to houses where you're having your basement, this one is not needed, because if not, water will be entering into your house. Is that okay? So that is that. And now, which load will be calculated? So that is that. And you can now see our reinforcement. You can now see the detailing. Is that okay? You can see it. You can see it. You can see how the thing came out very well, fantastic. Which we are going to be using our stone bridge also to do what? To detail this. Is that okay? With the help of stone bridge, we can still detail this one, so you can see it. As you can see, so you can see this is how you use what? You design your retaining wall. Is that okay? Cantilever retaining wall. So as you can see it here, as I said, you can see it. If you click on this, sorry, if you click on this, you can see cantilever retaining wall. So that is that. That is that. You can see even the property, sorry, the retaining wall quantity takeoff. So everything is being what? Have been given. So that is that. So from this one now, you can now export it to what? To AutoCAD. Is that okay? From AutoCAD, you can now use a stone bridge to what? To detail it properly. Is that okay? To detail it properly. So that is that. You can see all your reinforcements. You can see the arrangement. You can see all the dimensions are here. So you can see it. You can see it. Our stem top is what? 350. Our stem bottom is what? It's also what? 350. So that's why this first one stands for the top, which is from here to here, and this 350 down stand for what? For this, from this place to this place. Is that okay? So that is that. This is how to go about what? Your retaining wall. So thank you very much. Till I see you next time on this part. That is what? To deal with what? Other part of what? Of retaining wall. Is that okay? So that is this one we design without what? Without a toe. Is that okay? Or shear wall. Sorry, we design without what? A shear key rather. We design this without a shear key. Subsequent one, we are going to design the one with what? With what? A shear key. And those one that even at this point at the toe side where we have different dimension for a different level for it. All of this we are going to be designing, and even the one that what? The stem varies. The eccentricity it's not zero. At what point do you use those ones? Everything will be explained as time goes on. Is that okay? So that's why I said make sure you click on what? On subscribe button, and also like this video, so that anytime we post video, you can quickly get access to our video. So thank you very much. Till I see you next time, and I want to say bye.